Welcome to the next video. So last videos we were studying about structures. So today what we will be learning is about unions. Okay. So unions also is pretty much similar to structures with a very important key difference. Okay. So it is also enables you to create your own data type. So if you see the code written here, there is a structure defined here, a struct str date, then the members of the structures are 3 integers. Okay, and I have created another structure, date structure. I have initialized to 12/12/2020. So 12 will be for day, again the next 12 will be for month, and third 2020 will be for year. It will be in that same order as the definition. To start a union, so after defining this, I will tell you what is a union and what is the difference between structure and union. So it is similar, only thing is you have to use union instead of struct. So let's say UNI date. So the same structure I am trying to make with the union. So union also is more or less same as structure. It works the same way, but with a very important key difference. So let's say I am taking int day, int month, int year. Then after here I have to put a semicolon. So to declare a variable as a union of type uni.date, what you will do is union UNI date. So let's say date union. Okay, so both are same. So now what I will do is I will try to understand how much is the memory that is occupied by this union and by this structure. Then you will understand what is the difference between a structure and a union. Okay. So to find size of any data type, what you have to use is a size of operator. So we'll use that. Printf, the size of structure is, so the identifier is %lu, if you remember from our class previous videos, and that of union is %lu. Line here, comma, size of, so I can give this entire struct str date to get the size. I can also give the variable name. So both will give me same result. So for union I will give the variable name, size of date union. Right. So both way it works. Either you can write here instead of date union, you can use union uni date. Okay, so that also will work. Now let's run this. Okay. So the size of structure is 12 and that of union is 4. Okay. So the key difference is what is this 12, what is this 4. Okay. So whenever you initialize or create a structure, what happens is there are 3 integer data type. Okay. And size of each integer is 4. So if you want to verify that, you can write that also. The size of integer is %lu. /n, I can use a size of operator. Size of, I can use int. Just check that also. Okay. So size of structure is 12, union is 4, and size of integer is 4. Right. So each of these integer is of 4. So day is of 4 units, month is of 4 units, and year is of 4 units. So whenever you create a structure, what happens is, what is the sum of the each integer? So basically what structure does is, it will create space for each variable. So that means 3 integers are there, 3 into 4 is 12. So that is why structure is occupying 10 units of space. Right? Now if you look at union, what happens is, union will see what all members are there, what all different data types are there. So here it is all are integer, so no problem. It will take the size of the maximum, the member which has the maximum size, and it will define only that much space. Okay, so that is a key difference, first difference. So I'll just keep writing it here. Structure, union, right? So let's say space. So this occupies number of members times, or let's say sum of size of all members. Okay, so this will occupy size of the member with largest space requirement. Right, so this is one difference between structure and union. So both is more or less similar, but there is a key difference there. Okay, so the idea is whenever you take any member and put value in the union, what happens is it is using the same space to store the value. Okay, so to understand this further, what I will do is I'll try to give some value to union. So how to give value is similar to structure. You have to use the dot, then the variable name inside that is day equal to 12. Okay, so date union dot month equal to, let's say, 8. Date union dot let's say year is already defined there, year equal to 2021. Now let's say we will try to print the value of day in union is percentage %d. Okay, it's integer, that's why I'm using percentage %d. Date union dot day. So let's run this. So it is telling me the size of the year is 2021. Okay, now what has happened is when it stored day, it's stored in some space. Next, we change the value of month, or we added a value of month. This is also getting stored at the same place. So we have already seen there is only one space there. Then we added 2021, that is also going and getting stored in the same space. So that is why the last entry we got. Okay, so if you want day, what you have to do is you have to print this day after this. Okay, if you want month, you have to print the month immediately after assigning a value. So that means it can hold only one value. Okay, and that value will be the last assigned variable. What is the last assigned variable that you used? So let's say day, month. So this will be month. So this will be year. Run. Okay, so put a new line here. Okay, run. Okay, so first I assigned 12, so then I am printing 12, it is coming, no problem. Then I assigned 8, so 8 has gone and replaced this value. That is why 8 is coming. So this is a key difference between structure. If it was a structure, this value is always written because it is storing these separate members in separate spaces. But union is keeping everything together. It will see how many members are there. So members means what is the variable I am using inside the union. It will count which has the maximum size. In that same space, it keep on storing whatever value we are feeding. Okay. So that means when you want to, this is how you initialize structure. So if you want to initialize union, you can only give one value, 12, or let's say 14. Okay, so this value will be stored as the value of first member in the union. Okay, so if I just print this before assigning any value, I'll get the value 14. So that is this output. Value of the day in union is 14. Okay, so this is key difference. Again, I will write. So in structure, when you are initializing, we can initialize all members at once. So here we can only initialize the first member. Okay, so initialization, again I'm telling, this two is what is known as initialization. I am declaring a variable and I am assigning the variable at the same time. Okay, then as we already told, size of all members. So in line with this, all members are stored separately in memory. Only same memory space is used to store all members. That means values of all members, right? And the last one is we can change any member anytime. We can change and use one member at a time. Okay. So when is it helpful? Why do we actually do this? So it is also simple. Let's say you are in your program, you want 10 variables, but all the 10 variables is like you use the first variable, the usage is over. Then you go and use the second variable, then that usage is over. Then you go and use the third variable, then your usage is over. So basically all the 10 variables occupy 10 spaces, okay, when the program is being run. So, and they are not used simultaneously, and once one member is used, it is not further used, the next member is being used. In that scenario, what you have to do is you can always declare a union so that it will occupy only one space, one member each time you keep on using, but the same small space only you want. So in that particular scenario only you will be using union. So unions is a tool which will help us to organize our members and save a lot of space. Okay. Again, you should be very, very careful when you use union. Only it can hold only one value. Even though you have many members, it can hold only one value. Okay. So that is a key difference. So I hope this is clear to you. Union. Try to do more examples with union and understand this. This closes our structures and union. We will see in the next video with a new topic. Thank you.